In order to find the pH of a base, we first need to consider Kw, also known as the ionic product of water. Water can act as both an acid and a base. When it comes into contact with another water molecule, an equilibrium is set up, where one water molecule gains a proton and the other loses a proton, to form H3O+ and OH-. This can be simplified to just H2O dissociating into H+ and OH-. Now this looks very similar to other acid equilibria you may have come across, so we can write an equilibrium constant for this reaction. Ka is equal to H+ OH- over H2O. But very little of this dissociation is actually happening, so the water is essentially pure and its concentration is basically constant. This means the H2O term down here can just be absorbed into the Ka constant, giving the new Kw being equal to H+ concentration times by OH-. For pure water at 25 degrees C, Kw is equal to 1 times 10 to the minus 14. Because this is an equilibrium constant, it remains constant at a certain temperature even if you change the concentrations of the ions. So let's say we have an aqueous solution of sodium hydroxide, and the concentration of this is going to be 0.1 moles per decimeter cubed. So now the concentration of OH- ions is going to be much greater than it was in pure water, and because Kw has to be constant at a given temperature, that means the equilibrium is going to shift to decrease the concentration of H+ ions. So we can use Kw to find the concentration of H+ ions at a given OH- ion concentration. If we rearrange our Kw equation, we have H+ equals Kw divided by the OH- ion concentration. In this case, that's going to be this, which gives us 1 times 10 to the minus 13. Now all we have to do is take that concentration and plug it back into our classic pH equation. So that gives us minus log to the base 10 of 1 times 10 to the minus 13, giving us the final answer of 13. So a 0.1 mole per decimeter cubed solution of NaOH will have a pH of 13. So to summarize these steps, we had firstly using our Kw expression to find the concentration of H+. So that equation was this one here. Then we use the concentration of H+ we just found to find the pH. So that's using our pH equation like this. If you found this video helpful, please like and subscribe. My previous video is all about how to calculate the pH of acids, so if you're interested in that, there'll be a link in the description.